Please welcome Nell Shamrell Harrington, Senior Software Development Engineer at Chef.
Hello, everyone. I'd like to start off today with a question. What if you could build software once and run it anywhere? What if you could, whether it's a bare metal server, a virtual machine, or in a container? What if you could move a legacy application into the cloud without having to rewrite it? What if you could empower your applications to recover from failure on their own without the need for a central orchestrator? Well, I have news for you. You can do all of these things today with Habitat, a new open source technology from Chef. Habitat is application automation. It goes beyond infrastructure automation, beyond cloud automation, and it's the new world of application automation. Now, we'll go deeper into what this means in just a moment, but first, let's cover who I am. I'm Nell Shamrell Harrington. I'm a senior software engineer at Chef. I'm a core maintainer of the Habitat open source project. I'm also the co-host of the Food Fight Show podcast, where we discuss Chef, DevOps, and everything beyond and in between. You can tweet at me at @NellShamrell, or feel free to email me at nshamrell@chef.io, and I will put these details back up on the screen at the end of the presentation. So the reason I was asked to speak here today is because, as I mentioned, Habitat is 100% open source. It's distributed under an Apache license, and if you want to check out the code, head on over to github.com/habitat-sh, where you will see all the repos that make up Habitat. So before we go into exactly what Habitat is, it's important to first understand the why of Habitat. Why was it created in the first place? Well, the answer is pretty simple. Building and running software is very painful. You have different runtimes tied to different environments. You need one runtime for a Ruby application and a different one for a Java application. You need different packages for different flavors of Linux. You need a Yum package for Red Hat Linux and Deb packages for Debian flavored systems. Additionally, you need different types of packages for bare metal and virtual machines and container images. Now, Habitat seeks to alleviate this pain through building and running modern applications, through transforming applications, including legacy applications, into what we call modern applications. Now, a modern application has a few key characteristics. First of all, it must be immutable. It must be agnostic to runtime environment. It should reduce complexity when it comes to automating it rather than adding in complexity. And it should enable scaling. So that's the why of Habitat. Now let's cover what exactly Habitat is. Briefly, Habitat is a new technology to build, deploy, and manage applications in any environment, from traditional data centers to the bleeding edge containerized microservices of today. In Habitat, the application itself is the unit of automation. That application package we create contains everything we need to deploy, run, and manage the application. And the clearest way to understand how this works is to look at the workflows for both packaging and running an application with Habitat. So when you package an application with Habitat, it starts with the user. This is you at your workstation. It doesn't matter if it's Windows, Mac, Linux, Habitat works on all of them. And at that workstation, you're going to create a plan. This plan will include instructions on how the application should be set up wherever it is deployed, and we will look at a live example of this in just a moment. So when you're creating a package for a Linux system, you would write this plan in Bash. Eventually, you will also be able to create packages for Windows, and you would write those plans in PowerShell. Now, when you use that plan and the compiled application code to create an artifact that contains everything in one place. Now, this artifact is cryptographically signed with a key, and I'll show you how that key is used in just a moment. Then you can optionally upload that artifact to the public Habitat depot, where you can find Habitat packages by developers all over the world. Now, when it comes time to, if you'd like to check out the public depot, head on over to app.habitat.sh and click on Depot. And what you'll see there is you'll see an interface that looks very similar to this. And in this screenshot, we are looking for all Habitat packages uploaded to the public depot that will install Node. So this is how you package an application with Habitat. Now let's go through how you would run that application with Habitat. And this is where we use what we call the Habitat supervisor to actually run that package. So if you have your application artifact on the depot, you can find it on that depot, then pull that artifact from the depot and pull it onto wherever you want to run it. It will run the same on bare metal, virtual machines, and containers. Now, if you are not using the depot, you can also upload that package from your local workstation to wherever you want to run it. And we'll see an example of that in just a moment. So you then run that package as a service within what we call the supervisor. And we'll go more in depth into the supervisor and services a little later. So once you have that application running somewhere, in this example, it's in a virtual machine, you can still get information in and out of it through a standard RESTful API. This is really useful when you have something like a load balancer that needs to send traffic to that application, run health checks, and more. There's a standard RESTful API for it. And the real magic of Habitat comes when you have more than one instance of an application running. So let's say we have 4 virtual machines running the same package. The supervisors on each of these virtual machines form a ring. They will use that key we use to sign the package to decide whether to allow other virtual machines into the ring. They all have to be signed with the same key in order to be able to communicate with each other. And they do this communication over an encrypted gossip protocol, which they can later use to self-organize into different topologies. And we'll look at an example of that a little later too. So when I spoke to Jamie Windsor before I came onto the Habitat core team, he described Habitat as an umbrella over many components, all designed to allow you to build software once and run it anywhere. Now, many of these components are still in development, including the Builder service, which if you want to learn more about that, head on over to the Chef website and you can see a keynote from Chef Comp, which will demonstrate it. Now, a lot of other components are still in development, and even though they are very promising, I'm here to talk about what you can do with Habitat today, how you can create and run application packages nearly anywhere, how you can move existing applications into the cloud and give your applications the intelligence to recover from failure on their own, without the need for a central orchestrator or controller. I want us to understand what we can do with Habitat today, because this is an open source project, and this project will largely be driven by our community of users and contributors. Together, we will shape where it goes in the future. So first, we will discuss the Habitat supervisor. This is what you use to run your application packages. And again, this is where the true genius of Habitat shines. Next, we'll discuss the Habitat packaging format. This is what you use on your workstation to make that software artifact that can run nearly anywhere. So this is what you will run with that supervisor. And finally, we'll touch on Habitat with containers. Now, you can use Habitat without containers, but it really shines when it comes to working with containers like Docker. Habitat complements things like Docker and Mesosphere and Kubernetes and makes them work even better. So let's go ahead and start with the Habitat supervisor. The Habitat supervisor does a few things. One of the main things it does is act as a process manager. So this means when you pull that artifact from the depot onto whatever infrastructure you want to run it on, this Habitat supervisor will start up and monitor that package. It will also receive and implement configuration changes. Applications these days don't stay static for very long. So when a new version of that package is uploaded to the public depot, let's say for a security patch, the supervisor will be monitoring that depot, become aware of it, and pull in that new package, install it, and make whatever configuration changes are needed. And it also runs services. So before we go into a demo of this, let's briefly cover what I mean by a service. A service is one habitat package running under one supervisor. And the simplest example of this is one supervisor running one service on one piece of infrastructure, whether that's a bare metal server, a virtual machine, or a container. So one service running would look kind of like this. We'd have one virtual machine running one service under one supervisor. But that's enough with the talking. Let's look at a demo of this simple example. All right, so in this demo, I'm on a local workstation right here, a local Linux workstation. And in it, I have a habitat package that I just built. We'll look into exactly how you build these in a little bit. But this is my most recent build. Now, I want to deploy that to a virtual machine in Microsoft Azure. And to do that, I've already created that virtual machine, but I've done nothing more than create it. I am going to go ahead and SCP this package. Take the build right there. And I'm going to SCP that up to my Azure virtual machine. That's the IP address. And once I do that, it's going to SCP it up. And then I'm going to SSH into that same virtual machine so I can see this package there and then install it. So going ahead and SSHing in, and there is the package I'm going to install. We're on the virtual machine now. And in order to install that, I am first going to install Habitat. Remember, I've done nothing to this virtual machine other than set it up through the Azure web framework. So once I install Habitat, I can then install this package. Sudo hab install, and then I'm going to put in the package itself. And that's going to go ahead and install it, and I sped this up just a little bit for the sake of saving time. And then I am going to, before I can run this application, I need to add a hab group to my system. So I'm going to add that in. And once that is added, there it goes, I'm going to need to add in a hab user. And I'm going to add into that hab group, and then I can start the Habitat service. That is all I need to do in order to be able to start this application. Now, this is a node application, and it's running on port 8080 of my virtual machine. So if I head on over into my web browser and go to port 8080, there's my running application. So this was a bare minimum, bare virtual machine just spun up in Azure, and in that little bit of time, I now have a running application in it. Let's go back to the slides. So this was a simple example, one supervisor running one service, in this case, a Node.js application. But that's pretty limiting. When we go beyond one service, when we scale out, we need a supervisor ring. So let's look at an example of this. Let's say we start off with one supervisor on a virtual machine running MySQL, and we decide we want a MySQL cluster. So we spin up two more virtual machines and install the MySQL Habitat package on them. So since that MySQL package is signed with the same key, these three virtual machines will be allowed to form a supervisor ring. What this ring allows these virtual machines to do is to communicate with each other over that gossip protocol. Remember, all of this communication is encrypted. And with a cluster like this, it's common to use a leader-follower topology. What this means is once we have these three virtual machines running that MySQL service, they need to elect a leader. So Habitat has a built-in algorithm for electing a leader in a cluster such as this that does not require any human or any outside orchestrator intervention. So when we run that election algorithm, let's say it decides this one at the top is the leader. So that means it's going to receive all the write requests that come with that MySQL cluster. And that means these two at the bottom are designated as followers, and they'll receive the read requests that come into that cluster. Now let's say that something bad happens and that leader goes offline. Because they're in that supervisor ring, the other two are going to realize they cannot connect to the leader, and they're going to go ahead and take it out of that ring. So now we're down to two virtual machines, and at the moment, both of them are still followers. So they're going to hold another election to make sure they're in that leader-follower topology. So they hold that election using that built-in algorithm, And let's say this one on this side wins the election and becomes the leader. It will automatically start receiving write requests. And this one on the other side will become the follower and start receiving read requests. So all of this was done without the need for human involvement or an orchestrator's involvement. What this illustrates is that Habitat assumes that failures will happen and that they are normal. We don't try to anticipate every edge case in the beginning because, frankly, we just can't. There will always be something unforeseen that happens somewhere in an application's lifecycle. The remaining healthy components have the intelligence to self-organize and reconverge on their own. There's no central coordinator that reorganizes and reconverges them. Again, they have the intelligence to do this by themselves. So the Habitat supervisor supports two different topologies at this time. The first one is the one we just saw, that's the leader-follower topology. And then the next one is the standalone topology. And in this one, we assume that every member of the supervisor ring is working as an individual, but happens to be in communication with all of the others. So the supervisor is also in charge of handling updates to the package or configuration changes and rolling them out to the rest of the ring. So again, it's going to detect when a new release becomes available on that depot and then deploy it according to a defined update strategy. Now, the only update strategy currently supported is all at once. So that means when a new package becomes available, all of the supervisors in the ring will update to that new package immediately. However, we will soon add one called rollout. This means that a supervisor ring, say it has 4 supervisors, one will update, then the next one will update, and the next one, and so on. So only one supervisor will be updating at any given time. So that's the supervisor, which is used to supervise and manage applications packaged with Habitat. Now let's step back in the process just a little bit and talk about how we make that package for the supervisor to supervise. And we do that using the Habitat packaging format. This is what you use to create the artifact on your workstation. Now, these packages are in the heart format. We like to say it's because we heart you, but it actually stands for Habitat artifact. And these packages contain the compiled application itself and everything needed to deploy and run that application. That's that plan file we saw, which we'll see one in action in just a moment. And enough with talking about it, let's see this packaging format in action and go to the next demo. All right, so this case, again, I'm on my workstation. And I'm in a repo for a Node.js application here called My Tutorial App, and it has a Habitat directory and a source directory. So let's head on into source. This is where the actual application code is. And we've got a few files here. The first one we'll look at is the server.js. And what this file does is, as you can see, it gets the values of a few variables and starts a listening website. So after the server.js, we also have a config file, and this is where we have the values for those variables I just mentioned. So server.js is going to pull these values from this config file. And then after this file, let's go ahead and exit out of here. There we go. Let's also look at this package.json file. And what this does is it defines metadata for our Node application. In particular, it defines dependencies. This is going to be important in just a moment. So our Node application is dependent on the nconf package. So after that, let's go ahead and close out of here. And let's cd up one directory. Let's go ahead and do that. And then let's look at the Habitat directory. And this is where we're going to create that plan.sh. So this is kind of the core of Habitat. This defines how you build and deploy this application. So first of all, we have some metadata here with some information about our application. And the first thing I'm going to add in is the origin. This is kind of like the namespace for your application. And it's a way to store keys and use for key authentication on the depot. So after that, I've got my package name, which is My Tutorial App. And the next thing I need to define is any dependencies of this package. So it depends on core node, which we saw we were looking for in the public depot. It's a node package under the core namespace. And then we need to export a couple of things. So we are going to export a port variable for what port this application should be running on, and that is defined in a separate file, which if you want to see that file, head on over to habitat.sh and check out the tutorial. But we're going to take that variable listening port and assign it to the variable port in this plan. So next we need to define the exposed port. When we're running with Docker, we need to define which port we want to expose for that application to run on. So in this case, we're going to use that port variable we just created. And the next thing we need to add are what are called callbacks. So all we have so far is just metadata about our package. Now we need to define how we build and install it. So the first one is do build. That's our first standard callback. This defines, and it's written in Bash as you can see, how we build this application. So we're copying a few things and we're running npm install to install any dependencies. And then our second callback is do install. And what this does is it, also written in Bash, defines how we install that package on a virtual machine container wherever we're going to run it. So after that, we can go ahead and exit out of this plan. And then to build it, I'm going to head back into the root directory for my app, and I'm going to use what's called the Habitat Studio. The Habitat Studio is a true-rooted environment that's essentially a clean room to build your package. So you'll be able to build this and install it without affecting your local workstation. So when I head into the studio for the first time, it's going to install a few things. And then when I want to build that application using that plan we just created, all I do is run the command build. So I'm going to run that, and it's going to install my application, or it's going to build my application, excuse me. And I know that it successfully built it when I see this message, which is, I love when a plan.sh comes together. So after this, I can exit out of the studio now that I built my application. Let's go ahead and exit. There we go. And then if I look in this results directory, I'm going to see my freshly built package. So that's what we took in the first demo, put on that virtual machine and installed it and ran it. So I do want to add that this is only part of the process. There's a little bit more we need to do to make this runnable and deployable. If you'd like to see the rest of those steps, head on over to habitat.sh and again, check out the tutorial. And with that, let's head on back to the slides. So Habitat packages use Bash for packages that will run with Linux. Now soon, you will also be able to create packages for Windows using PowerShell, and that's currently in development. So along with running Heart packages with Habitat, you can also export them to other formats. And by far the most popular format is Docker container images. And with that, let's touch on Habitat and containers. Now, as we already saw in the first demo, Habitat does work very well without containers, but it shines the most when it's used with them. So getting a software package to run anywhere is very difficult. That's not a new problem. We all know that. Now, containers were supposed to solve this problem, but there's still some pain with them currently. And one of the biggest points is there's a major learning cliff between using containers in development and using them in production. Additionally, containers have a tendency to become black boxes, where we deploy them to different environments without fully understanding everything that is inside them, particularly when we're pulling them off of the Docker container registry. And this can introduce security issues. If I have an entire operating system in a container, but I'm only using part of it, I can potentially forget about the rest of that operating system and then not update it when new security vulnerabilities are revealed. So the reason for this is that traditional containers, if you can call containers traditional, I suppose, they've only been around a few years, but they start by building the operating system in that container first, then the application libraries, then finally the application itself at the very end. So this adds a lot of bloat and complexity to containers and probably a lot of things we don't actually need to use. What Habitat does is it turns this container workflow on its head. You start with just the application. Once you have that application, you add in the libraries to run that application, and then only at the very end of it do you add in a bare minimum operating system that is just enough to run your application and nothing more. That operating system starts with just /bin/sh. And then anything else your application needs, it can pull in through that plan.sh. So Habitat, again, starts with the application, and that minimal operating system comes later. The application itself is what declares those dependencies. We don't add in dependencies preemptively, and the dependencies are resolved from the application itself. And you still have that exposed API for external services. Even though my application is running in a container, I still have a standard API for a load balancer or any outside services that need to communicate with it. So when you create a container image with Habitat, you know exactly what went into the container and exactly what is configurable about that container. It's not a black box. Now let's look at this in action with our last demo. So let's head on over to the demo and let's see an example of exporting a Habitat package into a Docker container image. Here we go. So first thing is I'm back here on my workstation, and we've already built that package for my tutorial app. So we're going to head back into that studio. And this is where we can export that built package as a Docker image. It's very simple. You just run the habit package, export Docker, then define your origin and the name of your app. Now I have sped this up just a little bit for the sake of time in this demo, but it's going to go ahead and create that Docker container image. And then I'm going to be able to exit out of the studio. So let's do that now. And then I can start that Docker container. It's immediately available for use on my workstation. So I'm going to start it with sudo docker run. I'm going to pass it the port I want it to run on and tell it what Docker image to run on that container it's going to spin up. So it's going to do this, and it starts that application on port 8080 on my local workstation. And if I head on over into a browser, here we go, and put in localhost port 8080, I'm going to see my running application. So it's super quick and super simple to get your application into a container image. Going back to the slides. So when once you have that container image, you can run it locally like we just did, but it's not going to do much good just sitting on your workstation. So you can deploy that container using container scheduling services like Kubernetes, Mesosphere, Docker Swarm. One of the big questions I get about Habitat is it a competitor to these? It is not. It works with them. You can also use cloud-based container services, such as Azure Container Services or other cloud container services. Now, as we wrap up, there are a few things I would like you to take with you today. And the first is that you can build software once and run it almost anywhere. You can move a legacy application into the cloud without having to rewrite it. And you can empower your applications to recover from failure on their own. You can do all of these things today with Habitat. The key to remember is that Habitat is not infrastructure automation, it's not container automation, it's application automation. The application itself is what we're automating. So if you'd like to get involved, and I hope you do, head on over to habitat.sh/community. And with that, again, I'm Nell Shamrell Harrington. That's my contact info, and thank you.